this is practice 2, number 4 for collisions and conservation of momentum. So first we want to look at the problem of the astronaut is carrying an empty oxygen tank. So the astronaut carrying an empty oxygen tank, I'm just going to draw the astronaut like this, and then the empty oxygen tank will be like this. So they're stuck together. The astronaut has a mass of 80 kilograms, and the oxygen tank has a mass of 10 kilograms. Now they start together and then they come apart in the final. So the problem says by pushing the tank away with a speed of 2.0 meters per second. So then that means that the tank is going one way at a velocity of 2.0 meters per second, and the astronaut is going the other way at, we don't know, but their masses stay the same. So we know that much. So from there, we can identify what kind of collision is it. Is it elastic, inelastic, or explosion? Based on what we've been doing in class, it's going to be explosion because they start together and then come apart. Oh, I forgot that you should also determine the positive direction in your drawings. Okay. So from here, I like to do the algebra part next. So I'm going to say this is the astronaut and this is the oxygen tank. So the astronaut will be 1 and the oxygen tank will be 2. So in the first part, we can assume that they're just hanging out in space. So the velocity of them will be at 0 until they push apart. So the mass of the astronaut is 80 kilograms. And it's moving at 0 meters per second. So plus and equal. The oxygen tank is moving at, or it's at 10 kilograms. Its mass is 10 kilograms. It's also moving at 0 meters per second. Now for the astronaut, we know that its mass is 80 kilograms. We don't know its velocity. And we know that the mass of the oxygen tank is 10 kilograms. And it's moving in the positive direction at 2.0 meters per second. Now, if you drew your oxygen tank flipped where it's moving in the negative direction, you'll just need to add in a negative sign here. But since in my picture it's moving in the positive direction, I'm not going to put the negative sign for the velocity. All right, so then we'll just do algebra. 80 times 0 is going to be 0. And here 10 times 0 is going to be 0, so it's going to be 0 here as well. And it's going to be equal to 80 kilograms, I like to keep the units on, times velocity plus 10 kilograms times 2 is going to be, 20 kilograms times meters per second. So from here, we can combine like terms. We have 0 kg times ms. So these are like terms, and we can combine them, and they all combine to be 0 kilograms times meters per second is equal to 80 kilograms times velocity plus 20 kilograms times meters per second. And then from here, we can subtract 20 on both sides. So subtract 20 on both sides, and we get negative 20 kilograms times meters per second is going to be equal to 80 kilograms times velocity. and we're trying to get velocity by itself, so we're going to divide by 80 kilograms. That cancels out the kilograms, that cancels out the 80, and so we're going to divide by 80 kilograms. So this cancels out the kilograms, and negative 20 over 80 is going to be negative 0.25 meters per second is equal to our velocity. So the velocity of the astronaut is 0.25 meters per second in the opposite direction of the oxygen tank. Okay, and so for our graph, I think I'm going to make each box worth 10. Okay, each box is going to be worth 10. And so, I should have used a different color for the astronaut, but here we go. The astronaut will be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. And they're moving at 0 meters per second. So it gets an X there. And our oxygen tank is also moving at 0 meters per second. So it gets an X there. Now here, this is where my, so 1, 2, 3, 4, 5, 6, 7, 8. That's the 80 for the astronaut. And this will be for the oxygen tank. So the astronaut is moving at negative 0.25, and the oxygen tank is moving at 2 meters per second. So I think what I'm going to do is go by halves. So this will be 0.5, then 1, 1.5, 2. Okay, so negative 0.5, negative 1, negative 1.5, negative 2. So the oxygen tank is moving 2 meters per second. So then I'm going to color this in. And this is moving at half of 0.5, which is 0.25 in the other direction. So I'm going to color this part in. So once again, I apologize. I should have used a different color. Actually, maybe I'll go over it with a darker blue. So here we go. So this darker blue color represents the astronaut. And I'll do the same for the initial so that you can see it better. All right, and so that is problem number 4 for practice 2. If you have questions, make sure to let me know and email me.